Okay, so this is notes on how to do V.S.E.P.R. That is valence shell, like valence electrons, valence shell electron pair repulsion. This is the theory that explains how molecules are put together and what shape those molecules are. So what I'm going to do is just go through the basic construction of this and how it works, and then I'll try to demonstrate some of it for you. You have in front of you a sheet with a list of molecular shapes, and I will refer to that as we go along. So we'll start with the purpose of this, and that is trying to build molecules that make sense. And so the valence shell electron pair repulsion theory is a theory about how they're put together that's designed to keep electrons as far apart from each other as possible. So we start with a Lewis structure. That's why we've been doing Lewis structures. You need to be able to draw a Lewis structure, and I'll also say that for the time being anyways, this will refer only to covalent compounds because ionic compounds go together a different way. So once you've drawn a Lewis structure, you can look at that structure and how many electrons there are and how many bonds. So the second step in VSEPR is to count electron groups. So if you have a Lewis structure, the electron groups are unshared pairs of electrons, so the electrons that aren't bonded to anything, and bonds. Another thing that's important is we're only counting these groups on the central atom. Only the central atom, only the central atom. Have I gotten my point across? So ignore the atoms on the outside of the molecule. We're only talking about the central atom. So count electron groups, and that a group is a group of 2, a group of 4, a group of 6, it doesn't matter. A pair by itself, or a single, double, or triple bond, each one of those is a group. And then we look at how the atoms are positioned based on how those electron pairs are shared or not shared around the molecule. And I'll show you what that means. If you look at the molecular shape sheet that's in front of you, and just look at the first line, you see there's a column that says number of electron groups. So that would be shared or unshared pairs of electrons, and number of lone pairs. And if you know both of those things, you can see how the molecule is arranged and name its shape. So then I use this molecular shape sheet to determine the name of the structure based on where the atoms are and how many bonding groups and lone pairs are on that central atom, and it's only the central atom again. So just to give you a quick idea of what some of these look like, and then I'll show you the real thing. Here are some ball and stick models, and you see that these are three-dimensional models. So this is one of the things that I want you to get out of this is a molecule is three-dimensional, just like you're three-dimensional. And in order for that molecule to be three-dimensional, it has to have three-dimensional shape for where those atoms are. All right, so now we're going to change venue just slightly and see if we can make this work. Okay, so now it's me. If you look at this molecular shaped sheet, you see the number of electron groups, the number of lone pairs, electron arrangement, molecular shape. So let's take a simple molecule, carbon dioxide, and if you draw a Lewis structure for carbon dioxide, you find carbon in the middle and 2 oxygens on either side. And if you finish that, you'll see that there's a double bond between carbon and oxygen on both sides. So that's your Lewis structure. I don't care about the electrons that are out here on the oxygens, only about carbon. Now if you look at the sheet, you find number of electron groups. Well, the number of electron groups on carbon is 1 bond, 2 bonds. They're double bonds, but they only count as 1, so that's 2 electron groups. And the next column says number of lone pairs. There aren't any pairs of electrons on this carbon, if you draw a Lewis structure, that are by themselves. All the electrons are in these 2 bonds, so there are no lone pairs. The next line on here says electron arrangement. These electrons are arranged in a straight line. And in this case, so is the molecule. So on the sheet, it says linear and linear. The electrons are linear, the shape is linear. So here's a couple more molecules. Here's water. If I draw a Lewis structure, I have oxygen in the middle, 2 hydrogens attached to it. You should be able to do this, I hope. And here on oxygen, I have 4 electron groups. There's a bond, there's a bond. Each of those counts as a group. Here's an electron pair, here's an electron pair. These are called lone pairs because they're all alone. They're by themselves. 1, 2, 3, 4 electron groups. So in the first column of this sheet, you go down here to where it says 4 electron groups. Now if I look at the oxygen, there are 1, 2 lone pairs. So 4 electron groups, 2 lone pairs in that same row, 4 and 2. That says that the electrons are arranged as a tetrahedron, which is a 4-sided object. And so this is a tetrahedron. 1, 2, 3, 4, 4 sides to it. But these 2 are lone pairs. So the atoms are arranged, according to this, at 4 and 2. The atoms are arranged in this molecular shape in the last column, which is bent. So if you look at a water molecule, what you see is this. There's 2 pairs of electrons sticking out, and 2 atoms attached to the oxygen, and the molecule itself is bent. So what I want you to do now is look at the list of compounds on the board. There are 12 of them, and that walks you through this entire list of molecular shapes. So you can use the molecular models and the Lewis structures that you need to draw, and you can build each of these and see what it looks like with the Lewis structure and the shape.